Yes. So the first point which we have in probability is experiments. Let's try to understand what is the meaning of experiment. A process which results in well-defined outcomes is called as experiment. For example, when a coin is tossed, we'll get head or tail. So here the outcomes are well defined, that is head or tail. When a die is thrown, again the possible outcomes are 1, 2, 3, 4, 5 and 6. Still here the outcomes are well defined. So this is the meaning of experiments. Let's go ahead. We have a next point, that is a random experiment. This is very important. And what does random experiment means? A random experiment means all the outcomes of the experiments are known in advance, but any specific outcome of an experiment is not known in advance. Let's try to understand this with the help of an example. Children, when a dice is thrown, we are aware that the possible outcomes will be what? 1, 2, 3, 4, 5 and 6. But we are not sure when a die is thrown what will come. So this is nothing but it is an example of random experiment. Here the possible outcomes are known to us, but what will come, that is not sure, that is we don't know. Then one more example we'll have here. When a coin is tossed, so here the possible outcomes are known to us. What are the possible outcomes here? The possible outcomes will be head or tail, but we are not sure about the result. So these are the two examples for the random experiment. So here the two examples I have noted. Just once you can read and we'll go ahead. Then student, the next point which we have is very important, that is sample space. Now what is the meaning of sample space? See, the all the set of possible outcomes of an experiment is called as sample space. Here you have to just remember all the possible outcomes are known as sample space. For example, see, lot of time we are using the same examples of dice, coin, because they are general examples and very easy to understand. Now if I say you the what is the sample space for dice, now you say me what are the possible outcomes when a dice is thrown. You'll say that sir 1, 2, 3, 4, 5 and 6, and this is nothing but this is only called as sample space. So when a dice is thrown, the possible outcomes, the sample space which is denoted by S is 1, 2, 3, 4, 5, 6. These are the sample space. So see, here I have written some informations about the sample space. You can see that the set of all possible outcomes of random experiment is called as sample space. It is denoted by S. Each element in the sample space is called as samples point, and the number of elements in that set is called as n of S, that is number of sample point. Now see, something very important we have to study ahead, that is about the sample space. Now we should know about the sample space for when one coin is tossed, when two coins are tossed, when three coins are tossed, when one dice is thrown, when two dice are thrown, when cards are shuffled. Everything we should be aware. So here we are going to study in detail the sample space of each and every event. So I want you all to make these notes in your notebook. So let's go ahead. Now see children, here I have written on the board few examples when one coin is tossed. Now you say me, when one coin is tossed, what are the sample space there? Yes, you can see that when one coin is tossed, either it can come head or tail. So the sample space is S, and here you have tried all the possible outcomes. So when one coin is tossed, the possible outcomes are head and tail. So what is the total number of these points? It is 1, 2. So here we have n of S as 2. Okay. Then second we have something very important, when two coins are tossed. So when two coins are tossed, what are the possible outcomes? Now see, you need to imagine, take two coins in your hand and just throw it. What can come? On both the coins, head can come. Or what can come? On the first coin, head can come. On the second coin, tail can come. What can come? Again, tail can come, or tail head. So when two coins are tossed, the sample space will be HH, HT, TT and TH, and the number of sample points means total number. How many these are counted? 1, 2, 3, 4. So n of S will be here 4. This is very important. So when one coin is tossed, the sample space is H comma T, n of S is 2. When two coins are tossed, HH, HT, TT, th, and n of s will be 4. Then 3 coins are tossed. See, this is something very interesting, and I'm going to show you a trick for this to how to remember it when 3 coins are tossed. So yes children, as I said you, I'm going to show you a trick to remember when 3 coins are tossed. See, when 3 coins are tossed, what are the possible outcomes? Imagine 3 coins are thrown. So what can come? On all the 3 coins, head, head, head can come. Then 2, head, head, tail. Then head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. Now you may imagine how tricky it is to remember, and I have a trick for you how to remember this. So let's see a trick to remember the possible outcomes, the sample space when 3 coins are tossed. So students, the trick is, see, very interesting trick I have made. The trick is remember 4, 2, 1. Now see how to apply this trick. See what I am going to do. I am going to write 4 times head and 4 times tails. This is 4, and then I'll write here 2 times head and 2 times tails. Again 2 times head, again 2 times tails. And I have written 4, 2, 1, and 1 time head, 1 time tail. 1 time head, 1 time tail. Head, tail, head, tail. Now you read it. Okay, let's try to read it, and let's check it whether we got all the possible outcomes or not. See, the first is H, H, H. So see here, the first is H, H, H. I'll take a different color so that it will be clearly visible to you. Yes, see, H, H, H. Now you see here, this is H, H, H. The second is H, H, T. Now you see here, second is H, H, T. The third is H, T, H. So here we have H, T, H. The fourth is H, T, T. I have here H, T, T. I hope you are enjoying it. Then we have T, H, H, and here it is T, H, H. Then T, H, T, T, H, T, 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 H, T, T, H, and T, T, T. Here is the trick, children. So the easiest way to remember when 3 coins are tossed, remember the maths guru, that is Mr. Nisar, and the trick is 4, 2, 1. This is the way to remember when 3 coins are tossed. We have 4, 2, 1, that is H, H, H. 4 times head you write, 4 times tails, then 2 times head, 2 times tails, 1 time head, 1 time tail. I hope it's making a sense to you, and you have to remember this. It's very important when 3 coins are tossed. What is the sample space? And just a quick revision, what is the meaning of sample space? All the possible outcomes. I hope it is quite clear to you and you have enjoyed the way to remember it. Now something we have when one dice is thrown. See, very, very important. When one die is thrown, how you are going to remember? When one die is thrown, what are the possible outcomes? Yes, it's 1, 2, 3, 4, 5, 6. So the sample space, capital S, you will be writing in the curly bracket 1, 2, 3, 4, 5, and 6. And n of s, how many it will be? 6. I hope it's quite clear to you. Then the second is very, very important part. That is when 2 dice are thrown. See, I have just make an image which so that you can understand what will be the sample space when 2 dice are thrown. You imagine you have 1 die in one hand and 1 die in another hand, and together you have thrown the dice. Then what are the possible outcomes? You imagine, children, what can come? On the first die 1 can come, on the second die also 1 can come. On the first die 1, second die 2, 1, 3, 1, 4, 1, 5. In the same way, on the first die 2 can come, on the second die 1 can come, then 2, 1, 2, 2, 2, 3. Here I have written all the possible outcomes. So when 2 dice are thrown, we can see, children, here we'll have 36 possible outcomes. How many possible outcomes we'll have here? 36 possible outcomes. So when 2 dice are thrown, what are the possible outcomes? What is the sample space? I'll write in the capital S is equal to curly bracket 1, 1, 1, 2, 1, 3, 1, 4, and so on. Then 2, 1, 2, 2, so on. In the same way till 6, 6. And the total number, that is n of s, will be how much here? 36. So I hope the things are quite clear to you, and this is something very important what we are studying right now. Now children, let's discuss something more important again. Till now what we have discussed, 1 coin is thrown, 2 coins are thrown, 3 coins are thrown, 1 die is thrown, then 2 dice are thrown, and now we have to study something very interesting, that are cards. Yes, cards. So see children, here I have made a tree diagram, and this you have to make in your classwork and you have to remember it. It's very very important for you all. So let's see what are cards and how to deal with it. So children, you have to remember, yes, there are total 52 cards. See, you will have many questions on the cards in exam, even in the practice set you have so many questions in the cards. So I want you all to understand it very detail, each and everything very clearly. So total number of cards we have 52. Remember children, out of that half, okay, half of 52 is what? 26. So here you see 26 cards are red cards and 26 cards are black card. Total how many cards we have? Total we have 52 cards. Out of that 52, half, that is 26 red, 26 black. Now in the red cards, you might have seen this, many of you have played this, so you may be aware that in the red cards we have again two types of card, that is heart card and diamond card. Just you can remember by HD. In red cards you have heart and diamond. That also what? Half of it, 26 half. What will be the half for 26? That is 13. So you can say that 13 heart and 13 diamond. In the same way, 26 cards are black, so in that also half is club and half is spade. So 13 club and 13 spade. So now you say me, total number of cards are how many? Total cards are 52. Out of that half, that is 26, 26. 26 are red and 26 are black. In that red also we have heart and diamond, 13 heart, 13 diamond, and then we have 13 spade and 13 club in the black cards. I hope it is quite clear to you. Now you see here, I have just drawn that all 52 cards. Okay, you might have seen this everything. Yes, here you see here now. This is all your club cards. So 13 cards are of club, 13 are of spade, then 13 are heart and 13 are diamond. Now children, in the black cards, that is your spade cards. Now how the numbering is there, this is also very important for you to remember. Now you see the first card is called as, see many students say it as Eka, but in English we say it as ace card. Okay, so what is the name of this card? The name of this card is ace card. I'll write it over here. The first card is called as ace card. So this is ace, then 2 3 4 5 6 7 8 9 10, then 10 number. Then we have 3 something very important, that is jack, queen and king. So in this 13 cards, so if I say you 13 cards of spade, what are there in 13 cards? The first card is ace, then 2 3 4 5 6 7 8 9 10, and then jack, queen and king. These are the 13 cards of one set. Now children, there is something very important you have to remember here. These 3 cards, that is jack, king and queen, these are also called as face card. Why? Because the face is made on that. So if I ask you how many face cards are there in all, so you may say that sir, in all there are total 3 of 3 club, 3 spade, 3 heart, 3 diamond. There are total 12 face cards. Write it somewhere, very important. This questions comes lot of time in the exam. Total number of face cards here, how much we have? 12 face cards. Okay, 3 in each group. Now if I ask you how many ace are there, so you can say that's a total 4 ace are there. If I ask you how many king of black color are there, so you may say that sir, there are 2 king of black color. How many queen of black color? 2 queen of black color. If I ask you, see my questions very important, huh? How many jacks are there? Now if I ask you in general how many jacks are there in 52 playing cards, so you should say that sir, there are 4. One is in heart, diamond, club, spade. Okay, so there are 4 jack. So these are something very important. So children, just quickly we'll revise what we have seen about 52 cards. Out total 52 cards are there, 26 black, 26 reds. Out of that red we have 13 13, 13 heart, 13 diamond, 13 club, 13 spade. See, the question can come to you, how many spade cards are there? So total how many spade cards? 13 cards. I hope it's quite clear to you. We'll go ahead. So children, the next point which we have is equally likely outcomes. Now what does it mean and how it's important? See, if I say you, let's take an example to understand what is equally likely outcomes. See, I have written here, in case of tossing a coin. See what happens, it is known in advance that the coin which land with its head or tail up. We know that when we are going to throw a coin, either head will come or tail will come. It's reasonably assumed that each outcome, head or tail, is as likely to occur as the other. What does it mean? it means that we say that there are equal chances for the coin to land with its head or tail up. It's, I think it's all clear to you that when we throw a coin, the possibility of getting head and the possibility of getting tail both are one and the same. So that's why we say here, or these are equally likely outcomes. Okay, referring to this, the terms used in this chapter, we say that the outcomes head and tail are equally likely outcomes. Okay, then one question I have for you, do all the outcomes are equally likely outcomes? What do you feel? Let's try to get this answer in the next part. Yes. Are the outcomes of all experiment equally likely outcomes? So let's understand this with the help of an example which I have quoted for you. The example is, suppose a bag contains 6 red, 2 yellow balls. Now let a ball be drawn from the bag without looking into it. The ball that will come out will either be red or yellow ball. Is it because I have kept only two balls, red and yellow? Now, are the outcomes, a red ball and the yellow ball, will be equally likely? So the answer here is no. Why? Because they are not equal in number. Reason? Since the bag contains 6 red and 2 yellow balls, then in a single draw of a ball from this bag without looking into it, it is more likely to get a red ball than a yellow ball. Why? Because red balls are 6 in number, yellow balls are 2 in number. When you are going to take out the balls, so more chances is of red ball than the yellow ball. So I can say that hence the outcomes are not equally likely. However, if the bag contains equal number of red balls and yellow balls, the outcomes are equally likely. I hope the concept is quite clear to you, when the outcomes are equally likely and when the outcomes are not equally likely. Let's go for the next point, children. Yes, the next point we have, that is, what is the meaning of event? An outcome of a random experiment is called an event. So in other words, an event is something that happens, okay, on tossing a coin. The possible outcomes is a head or a tail. Here getting a head or a tail is an event, that event of an experiment of throwing a coin. See, it's not something very important to know, just as a part of syllabus we have a term event, that's why I'm explaining you. So yeah, what is event? Event is something that is happening. So when a coin is throwing, that is the event. When a dice is thrown, that is an event. So when a cards are shuffled, that is also an event. So whatever something happens, that is called as an event. We'll not waste more time on this small part, we'll go ahead. Now children, now the something very important, as the name of the topic is probability. Now actually we are entering in the topic and we'll try to understand what is the meaning of probability. See, here I have written a very interesting example so that you can understand it very easily. Let us think of a simple experiment. A bag contains 4 balls of the same size. Now 3 of them are white and the 4th is black. You are supposed to pick one ball at a random without seeing it. Then obviously possibility of getting a white ball is more. So in mathematical language, when possibility of an expected event is expressed in number, it is called probability. So what is actually probability? See, probability is the possibility of getting something. What are the chances of getting something? When it is expressed in numbers, so then we can say that that is called as probability. Okay, so now here I have given an example where we have 4 balls and out of them 3 were white and 4th one is black. If I am asking you whose chances, when we are going to take out without looking to it, whose chances is more of getting, so you will say that, sir, obviously white balls are more in number, so the possibility of getting the white is more. So when this is expressed in the numbers, the possibility of getting something, that is called as probability. And see, something very important I have mentioned here, it is expressed as a fraction or percentage using a formula. See, now in ICSE board and in state board, even in the CBSE, we are always dealing with more in fraction rather than percentage. So let's understand ahead. Yes, what is the formula to calculate the probability? See, this is the most important part of the topic. Probability of an event is number of favorable outcome upon total number of possible outcome. So how to calculate a probability? Number of favorable outcome upon total number of possible outcome. Let's take an example, children. Okay, if I ask you What is the probability of getting a vowel in English alphabet? What you will do here? What is the formula for probability? You say me, it's number of favorable outcome upon total number of possible outcome. What question I asked you? I asked you what is the probability of getting a vowel. So now you say me how many vowel are there? So I'll say that sir, A, E, I, O, U. There are 5 vowel. So number of favorable outcome. So favorable outcomes here are 5. And total number of possible outcome, you have to find the probability of getting vowel from English alphabet. So total how many English alphabets are there? That is 26. So the answer will be favorable are 5. We want whatever we want, we'll keep it in the numerator. Favorable outcome, that is 5 upon total possible outcomes are 26. So the answer will be 5 by 26. And this question was asked in the board exam. See, I have written that example over here. Yeah, you can see that example here. I have written here, find the probability of choosing a vowel from an English alphabet. So the answer will be 5 by 26. Come on, I'll ask you one question. Try to give this answer orally. What is the probability of getting head when one coin is tossed? So you'll say that sir, there are only one head, and when a coin is tossed, total number of possible outcomes are 2. So favorable outcome is 1 head, 1 by 2 is the answer. Is that clear to everyone? I hope it's making sense to you. So what is the formula for probability? That is number of favorable outcome upon total number of outcome. Children, here there is something very important I have written here. This is asked lot of time in the exam. What is the range of probability? Now let us discuss this in detail in the upcoming part. Yes, so that is, now we have a range of probability. See, I have written here one example so that you understand what is the range of probability, and lot of questions are asked on this. A bag contains 10 blue balls of same shape and size. A ball is drawn from the bag without looking into it. Now see, we have 10 blue balls. Okay, find the probability that the ball drawn is blue. So now it's common sense that when you are going to draw, I'll write it over here so that it will be more clear to you. So when I say you, I have to find the probability of blue ball. Okay, how many blue balls are there? 10 blue balls are there. So I can say that number of favorable outcomes are also 10, and total number of outcomes are also 10. So 10 by 10, the answer will be what here? 1. Is it? So here you can say that when you are going to draw the blue balls, 100% blue ball is going to come. So I can say that the probability of getting the blue ball is 1 here. So see, 1 in terms of fraction, it is the highest number, and 1 means what? 1 means 100%. So there are chances that where we can get the probability 100%, and whenever the probability is 100%, do remember it is called as sure event. Now children, in the same question, if you will see, here I have written what is the probability to calculate the yellow ball from the blue ball. Can you answer this question? If their bag contains 10 blue balls, what is the probability to calculate yellow ball from that? So your answer will be for sure, sir, it will be 0. Okay, we cannot get an yellow ball from there. Here the number of favorable outcome will be 0 upon total number of outcome will be 10, and here obviously the probability will be 0. So what you will remember from here children, the lowest value of probability is 0 and the highest value of probability is 1. So you can say that probability lies between 0 to 1 in terms of fraction. And if I say you in terms of percentage, it will be from 0% to 100%. Do remember this, very important. Okay, so this is the question. Blue balls, the probability will be 100%. Yellow ball, the probability will be 0. So what is the range of probability? What you will remember from here, which is very important, probability is always greater than or equal to 0, greater than 0 or equal to 0, and always less than or equal to 1. So this is very important point which I said you right now. What is the range of probability? That is 0 to 1. In short, you can say 0 to 1, or in mathematical term, you can say that probability is greater than 0 equal to 1 or less than or equal to 1. Sorry, probability is greater than equal to 0 or less than or equal to 1. I think it's very clear to you and you are enjoying the session. See, there are something special names for this that also I want you all to understand. Right now I said you children about the probability, what is the range of probability. Now see here something I have written which is called as sure event. See, as the name itself indicate, if an event that has 100% probability of occurrence is called as sure event. Okay, in the previous example the probability of getting a blue ball was 100%, so that is a sure event. So what is the probability of sure event? That is always the probability of sure event is 1. And see, one example I have written here, what is the probability that the number obtained after throwing a die is less than 7. See, when you throw a die, what is the probability of getting number less than 7? So you'll say that whenever we throw a die, the possible outcomes are 1, 2, 3, 4, 5 and 6. They are always less than 7. So it means here the probability is 100%, that is 6 by 6, 100%, that is 1. So this is called as sure event. And then we have impossible event. So what is the name itself indicate? Impossible event means the probability of this event is 0. Okay, the same example, see, I have written here, given above, it is possible to get a number 7 in a single throw of die. So when you throw a die, is it possible to take get an event number 7? So you'll say that no sir. So the probability of getting number 7 is 0. So when your probability is 0, that is called as impossible. When your probability is 100% or probability is 1, that is called as sure event. I hope it is quite clear to you all. Now children, this is the very important part of our syllabus, that is complementary event. Now what is the meaning of complementary event? See, it's very easy for us to understand. A complementary event occurs when there are only two outcomes. There are only two outcomes. For example, clearing an exam or not clearing an exam. Yes or no? There are only two things. Either you will clear the exam or you will not clear the exam. Again, you say it rains or it does not rain. These both are complementary event. So what does complement means then? Complement means the exact opposite of an event. So see, this way it's very important for us to understand. Let's understand this in detail. Yeah, now here I have written example. Consider the example of tossing a coin. So let P of A denotes the probability of getting a tail when a coin is tossed. So P dash of A denotes the probability of getting a head. See, so the probability of getting a tail plus probability of getting a head is 1. So here I'll give you a better example for this. You remember the complementary event can be written as probability of getting something, that is P of A, plus probability of not getting something, that is P dash of A. The sum is always 1. If I say you tomorrow it will rain, so what is the complement of this? You will say that tomorrow it will not rain. Okay, so if the raining probability is 50%, what is the not raining probability? That is also 50%. So you remember complementary means what? That is an opposite of an event. If I say you he will pass in the exam, what will the complementary for this? He will fail in the exam. Okay, and see, the sum of this always it will be 1. So P of A plus P dash of A, that is nothing but it is equal to 1. See, whatever the concept which we have studied, this is a conceptual video. These concepts you have to see again and again, write you in your notes, and I'm also going to send you the notes for this. So remember this, these are very important things. And children, now we have studied the concept. Now we'll solve the exercise questions, many questions, and then we'll apply that concept. Then each and everything will be very clear to us. So I hope you have enjoyed it, and let's see in the next part. Thank you.